Okay, let's unpack this. We've all seen AI as this brilliant conversationalist, right? A super smart chatbot, you ask something, and boom, you get this amazing answer. But the AI that's really going to change things, the one for the next decade, it doesn't just wait for you to ask. It's proactive. Imagine an AI checking flight prices for you, sees a big drop, checks your calendar, and just books your trip, all automatically, talking to different apps. That kind of independence. That takes some serious next-level engineering. Today, we're diving into the advanced stuff, the architectures that make that kind of autonomy actually work.
Welcome, everyone, to the deep dive. So if you're already good with the basics, LLMs, vector databases, RAG, then you are definitely ready for what's next. Our mission today: go beyond those fundamentals. We're hitting 10 critical advanced concepts, stuff architects, developers, anyone planning AI strategy really needs to grasp. We're going to figure out how AI connects to the real world, how it actually reasons, learns on the fly, and super important, how we make it affordable and fast enough to deploy. We'll look at how AI takes action, how it gets smarter, and how engineers make it efficient. Let's start with how AI gets out of its virtual box.
Yeah, that's the big hurdle, isn't it? An LLM, just by itself, it's kind of trapped, lives in its text world. How does it actually reach out and do something?
Yeah.
Talk to an airline's booking system.
Right. It needs a standard way to shake hands, basically.
Yeah.
And that's where the Model Context Protocol, MCP, comes into play. Think of it as the essential bridge, the agreed-upon language for taking action. MCP sets up a structured way for the AI client, that's usually the wrapper around the LLM, to talk to outside systems, which we call MCP servers. It's like a really formalized API structure.
Okay, so if the LLM figures out, I need to book that flight, it uses MCP to frame a standard request, like call the Indigo booking server, use flight 1020, date X, something like that.
Exactly like that. And this is huge because it brings in security and reliability, standardizing how they talk. That cuts down the risk of weird stuff like prompt injection or the model just making up API calls. It really shifts AI from just talking about tasks to reliably doing them in real systems. It's the plumbing you need for actual digital agents.
Got it. So MCP handles talking to the outside world. But inside, the AI needs to remember what's going on, what we've talked about. That sounds like context engineering, which is way more than just writing one good prompt at the start.
Oh, definitely. This is the really sophisticated art of managing that ongoing conversation history. You've got that limited context window, the model's short-term memory. You have to work around that and make it feel deeply personal. I mean, if you're interacting with an AI agent over weeks, it absolutely needs to remember what you like, what you didn't like last time, your specific rules.
And keeping that straight. Honestly, I still wrestle with prompt drift myself sometimes.
Yeah.
You craft this perfect starting instruction, but 30 messages later, the AI seems to have completely forgotten it.
Yeah, we fight that with some clever tricks. You can use a sliding window, just keeping the most recent chat history in focus. Or, more advanced, smart truncation. That's where you use a smaller, faster AI to kind of summarize the long history before feeding the important bits to the big model. It's all about creating this dynamic, hyper-relevant context on the fly.
That sounds crucial for making a generic chatbot feel like a personal assistant that actually gets you.
Absolutely. It's what delivers that coherence, that personalization, especially when conversations get really long and complex and twisty.
Okay, which brings us neatly to the big payoff here. Agents. These are the systems that really run on their own. We've given the AI access to the outside, MCP, and a memory, context engineering. What's the final piece?
Initiative. That's the key difference. An agent is autonomous. It has planning skills. A chatbot just reacts to what you say now. An agent. It takes action based on a goal you might have set days, even weeks ago. So this agent has memory, it can use tools through MCP, and critically, it can break down a big, complex goal into lots and lots of smaller steps. It executes them one by one, checks if it's working, corrects course if needed.
I love that autonomous travel agent idea. You tell it once, book my usual vacation when the price hits the sweet spot. And this agent, just running quietly in the background 24/7, is watching fares, connects to the airline, the hotel, checks your calendar, and does the whole thing without you needing to nudge it again.
It's that jump from just reactive help to being proactive, strategic. These things act like digital employees working around the clock.
Right, so we've built a system that can act. Now, how do we make sure its actions are, well, good, aligned with what we want, and genuinely smart? Let's start with reinforcement learning, RL.
RL is all about shaping behavior. You train the AI using a system of rewards and penalties, essentially, optimizing what it does based on human feedback. Think kind of like training a dog with treats. So the process is the model gives you a few possible responses, a human picks the better one, and that choice gets turned into like a mathematical score. If your choice was good, all the internal calculations the model used to get there get nudged in a positive direction. Bad choice, nudged negative.
So you're steering the model's path through its huge possibility space towards outputs we find useful or helpful.
Precisely. And it's really powerful for optimizing very complex behaviors. Like if you want an AI that's consistently helpful, polite, but also thorough, RL is great at shaping that kind of nuanced output, maybe better than just showing it examples. But there's catch. RL is great at optimizing the behavior, but it doesn't always build deep understanding. It can learn the pattern of what response makes the human happy without truly getting the underlying facts.
Ah, okay. That's a subtle but really important point. So to make sure the logic itself is sound, we need something like chain of thought, say AT. This is about making the AI show its work, right?
Exactly. Hardy forces the AI to break down the problem. We're not just asking for the final number. We're telling it, show me the steps. Make it explicit, like how a person would solve it on paper. So if you ask it to calculate, say, a tricky sales commission with different tiers and taxes, it won't just give you the dollar amount. It has to spell out. First, convert the percentage, calculate tier 1, calculate tier 2, add them up, maybe round it off.
That focus on showing the intermediate steps seems vital for trust and for fixing things, especially in fields like, I don't know, engineering or finance, where a mistake in step 2 messes everything else up. You can see where it went wrong.
It absolutely cuts down on those multi-step errors because the model is kind of checking its own work as it goes. It makes the LLM a much more reliable reasoning tool.
But Coty is still kind of following a known recipe, even if it shows the steps. The real frontier, reasoning models, that's where the AI starts to figure out the recipe itself for new problems.
That's exactly it. That's the cutting edge right now. These models are built to figure out how to tackle problems they've never seen before, not just applying patterns they memorized during training. They use really sophisticated strategies, things like tree of thought, where the AI explores multiple possible solution paths, like branches of a tree before picking the best one, or graph of thought, which can handle problems where steps aren't just linear, they depend on each other in complex ways.
Okay, so if chain of thought is like following a marked trail, reasoning models are like expert navigators charting a course through totally unknown territory, maybe grabbing different tools as needed, picking the best strategy for something completely novel.
It's about cognitive flexibility. You see things like OpenAI's O1 or DeepSeek R1 really pushing here. It's aiming for that true strategic thinking needed for, say, scientific breakthroughs or designing complex systems.
That kind of thinking power probably needs more than just text data. Let's shift gears to data types with multimodal models.
Right, because the world isn't just words. These models are trained to handle multiple kinds of data at the same time, text plus images or video or audio. And the big advantage, it's how they learn. Imagine an AI that hasn't just read millions of sentences about cats, but has also seen millions of pictures and videos of cats. It builds a much richer, deeper, almost multi-sensory understanding of catness than a text-only model ever could.
Yeah, that deeper understanding seems key for applications where different data types merge,
Right.
like analyzing medical scans alongside doctor's notes or creating marketing campaigns where the images and text really work together seamlessly.
Exactly. It's not just linking different data, it's fusing the concepts together at a deeper level.
Okay, now let's talk efficiency.
Yeah.
Because not every task needs a planet-sized AI. There's a big move towards small language models, SLMs, too.
A huge move. Yeah, we're talking about much more focused AIs. Maybe 3 million parameters, up to a few hundred million.
Right.
You trade that broad general knowledge of a giant LLM for incredibly sharp, expert-level skill on one specific narrow task. And the benefits are massive. They're way cheaper to run, they're much faster, and you get tighter control, especially over your own private data. You can fine-tune an SLM on your company's specific jargon or processes and get amazing performance just for that niche.
So instead of paying for the giant general practitioner LLM for everything, you deploy a cost-effective specialist, SLM, maybe one for customer service queries, another for summarizing legal docs that does its one job brilliantly and cheaply.
That's the play. It's the smart way to specialize and scale AI across very specific business functions without breaking the bank.
But what if you want the smarts of the big model, but need the speed and cost of the small one? That's where distillation comes in.
Precisely. Distillation is this cool teacher-student process. You take a huge, knowledgeable teacher model and essentially compress its wisdom into a smaller, faster student model. How? Well, you feed the same prompts to both models. Then you train the student model, not just to get the right answer, but to mimic the way the teacher model arrives at its answer, matching its internal patterns and probability outputs.
So you're basically downloading the teacher's expertise, or most of it, into a lean, production-ready student.
That's the idea. You want a smaller, faster model that's really optimized for running millions of times in production, saving time and money. You usually accept a tiny, almost negligible loss in nuance, but gain massively in efficiency.
And the final optimization trick, really down on the weeds technically. Quantization, shrinking the memory footprint.
Yeah, this one's purely about efficiency. It's about reducing the precision of the numbers the model uses for its internal weights. So instead of using super precise, like 32-bit floating point numbers, you compress them down, maybe to simpler 8-bit integers. It's kind of like saving a huge high-res photo file as a smaller JPEG. You lose a microscopic bit of fidelity, maybe, but the file size reduction is enormous. Quantization often slashes the memory needed by like 75%.
And that smaller memory size, even with almost no noticeable change in output quality, drastically cuts the cost of running the model and lets powerful AI run on way less powerful hardware.
Exactly. It's what makes it feasible to run impressive AI on your phone or on small sensors, edge devices. Whoa. Imagine scaling that efficiency across like a billion queries a day globally. That's how this tech becomes truly everywhere.
Wow, okay. We've covered a lot of ground with these 10 concepts really fast. Let's try and weave it all together now. How do these pieces fit into a complete modern AI system?
Okay, let's trace a complex request. Input comes in, gets tokenized, the system needs context, it grabs internal knowledge using RG, and crucially, uses MCP to pull in real-time external data or trigger actions out in the world.
Then the brain kicks in, the reasoning core. The transformer architecture chews on all that info. It might use chain of thought to ensure the steps are logical and transparent, or even advanced reasoning models to figure out the best strategy on the fly. And if there's images or audio involved, multimodal capabilities handle that.
And this whole thing isn't just a one-off process. It's likely running as an intelligent, proactive AI agent. That agent is using sophisticated context engineering to manage the long conversation or task, remembering what happened before.
Right. And its overall behavior, the way it responds and acts, has been fine-tuned using reinforcement learning to make sure it aligns with what users actually want and find helpful.
And then finally, before it ever gets deployed to millions of users, that whole architecture has been squeezed for efficiency. Its core knowledge might have been compressed using distillation from a bigger model, and its final memory size shrunk drastically via quantization.
Yeah, getting comfortable with this whole vocabulary, it gives you a massive strategic edge. You could design smarter systems, make better choices, like, do I need a specialized SLM here or a big LM hooked up with MCP and RG? You can cut through the hype. Knowing this stuff is potential power, but using it, that's real power. You now have the language for this next wave of AI. So what should you do? 3 things. First, start using this language. Put terms like agent, MCP, COT into your notes, your discussions, your project plans. Show you understand what's under the hood. Second, look at the AI tools you already use. If something acts proactively, ask. How does it remember things? Is that context engineering? Is it acting like an agent? Try to deconstruct it. And third, don't try to master everything at once. Pick maybe 2 or 3 concepts that feel most relevant to what you do. Maybe it's agents, RAG, and multimodal if you're building user-facing apps. Go deep on those.
Yeah, because understanding these architectural choices means you're not just reacting to AI trends. You're actually equipped to lead the next phase of building genuinely smart, useful systems.
Because really, these concepts show the future isn't just about making models bigger and bigger. It's about smart integration, making them efficient, helping them learn continuously, building systems that can actually connect, think, and act for us in the real world.